Yeah, students, today we discuss about the very important chapter, the realm, which we have already discussed, a brief atmosphere. Atmosphere is mainly a study of gases, we can say, because it's composed of sea of gases, of many different type of gases, dominating oxygen, nitrogen. These two composed of other gases. And we breathe air, we take oxygen out of this air, and we breathe out carbon dioxide. So that is the main pattern of human beings. So we take oxygen and we give out, we breathe out carbon dioxide. And atmosphere is having these gases, different type of gases. It's not only protecting us from the sun rays, also it is giving life to the other plants, animals, and other life. So without atmosphere, without air, there is no possibility of life. So today we discuss about the other gases and what sort of the importance of the air. Air has got the wind, moving air is called wind. So wind has got its own property. With the help of wind, water coming from the oceans is going upward and becoming clouds, and then due to the precipitation we get rains, and these rains again erode the rock material, and we are getting the different type of soils. Through these soils we can grow vegetables, fruits, and other important crops. So in turn we get carbohydrates, proteins, fats, sugars, other minerals, etc. from these plants. So and these plants, the very interesting thing is plants take carbon dioxide with the help of water under the sunlight. They become and other byproducts. It's nothing but glucose. That means this is nothing but pure photosynthesis, without which you can't get any food from the plants. So we get all these fruits, vegetables, and other grains from these plants just because of this carbon dioxide, water, and importantly sunlight. These atmospheric winds transports water from the oceans, as we have discussed, like forming rains. So these rains not only giving us water, the fresh water, also erode the rocks, and we have discussed like weathering, transportation, deposition. So and we are getting different types of soils from these rocks with the help of winds only. And you can imagine, without wind we can't even fly our kites, the beautiful kites, and we can't get the sounds, musics, the different kinds of music we can only get with the help of atmospheric winds. If you go for a vacuum where there is no air, you can't hear any sound or even any different types of music also. That means wind helps us even for the sounds of music, and flying our kites. Even birds fly, they soar with the help of winds. And also these winds will help us to get other rains and other stuff. Atmosphere is a thin blanket surrounding the earth. It's like NASA. As you know, NASA, National Aeronautics and Space Administration, describes that this atmosphere is like if you think that earth is a basketball, and atmosphere is nothing but like plastic cover wrapped on it. So like that they have explained in some terms, like, these gases is a blanket. Imagine this blanket is just like very thin, we call is 1,000 kilometers from the earth, this blanket of gases, or you can say it's atmosphere. So these gases, they compress and expands. You can stuff this gas inside a small hole, for example in your cycle tube, that we stuff more air and this kind of compression is called as nothing but compression of gases, wherein which you can stuff more and more this gas or air inside the very small holes. So atmosphere is composed of these gases, mainly oxygen and nitrogen. Oxygen itself is having 21% of total volume of the gases, air, and nitrogen is itself 78%. So you can imagine only these two elements, nitrogen and oxygen, is covering 99% of total volume of the gases, and rest 1% consists of several different kinds of gases, like methane, natural gas we use in our cylinders to cook. So that is nothing but a gas, methane, also available in the atmosphere, and argon, neon. So all several other gases like carbon dioxide is present in that 1%. Yeah, apart from dominating oxygen, nitrogen, we have the other important gases. For example, water vapor, also a gas form of water, that. It's composed 0.4% of total volume of our air and atmosphere. And CO2, 0.03% also is having the gas, and the ammonia, ozone, methane, argon, neon, etc. These are all the gases composed of this atmosphere, and having less than 1% of the total volume of the gases. Including this, we have the dust, fine dust particles, usually we call as particulates. Particulates are nothing but the fine dust present in the atmosphere, and you can see this fine dust. For example, if you have seen the sun, orange sun, during sunset time and even during the sunrise time, this orange color is how you got this, just because of this particulates. Particulates helps, and also the conditions also will affect, atmospheric conditions also affect with the help of these particulates, this fine dust. And this fine dust formed how? Due to human activity. For example, if you are burning a fire wood, this wood will give the blackish ashes, and these ashes will mix up with the other gases. Likewise, sandstorms also will mix up these fine dust particles, and natural forest fires also will form this kind of dust particles. So these also, it's like, includes our atmosphere, this blanket. So these particulates benefits us, at the same time they cause problems too. Yeah, these particulates causes problems. What kind of problems we see usually? For example, if you feel more dust in the atmosphere, in the air, it makes more difficult for us to breathe. So it makes more difficult to breathe. At the same time, if they fall on the leaves, for example, if they settle on the leaves, it makes, so it causes the photosynthesis cannot be taken because the sun rays are covered, and they are not touching this leaf. That means once if they fall on the leaves, they can't even grow, because of there is no process of photosynthesis. They can't take even sun rays directly because of this dust is covered these leaves. So this kind of problems also caused by these particulates. And particulates also alters the temperature. For example, and even rainfall. For example, if you are getting the rain, for example, if someone is expecting today the rain, so you are not getting that rain just because of these particulates, because they form the layer and they disturb the and they alter the temperatures. At the same time, they alter the rainfall also. So that is about your particulates. Yeah, students, today now we will discuss about the structure of atmosphere. So just like as we have already learned, the interior of the earth, there are three layers. Similarly, the exterior of the earth, like for example the blanket which we are discussing about, the sea of gases, also has got the various layers. They are not like uniform in the characteristics and also the chemical composition. So now we discuss about the what exactly that layers composed of, and how many types of layers we have, and what is their characteristic, and what is exactly these layers will do. So based on the chemical composition, this atmosphere is divided into two layers. One, homosphere, having the uniform chemical composition. It's a uniformity you can observe in homosphere. Whereas hetero, as you know, homo is equal or similar, and the heterosphere, it's mixture. It's not similar or equal mixture. It's hetero is nothing but there is no uniformity in the chemical composition. So based on the chemical composition, we have homosphere and heterosphere. So homosphere, you can see this homosphere above the earth layer crust up to 90 kilometers. So up to 90 kilometers you can see the homosphere layer, and above the 90 kilometers you can see hexosphere, or you can say heterosphere. So this again, homosphere is divided into three layers based on the density, like the very important troposphere, stratosphere and mesosphere. You can observe these tropo, strato and mesospheres in homosphere. Whereas in heterosphere we see ionosphere, or you can also call as thermosphere and exosphere. So these exosphere and thermosphere are located above the 90 kilometers from the earth surface, above earth surface 90 kilometers, where you can see the satellites and other spacecrafts. Yeah, students, as we have seen, like based on the chemical composition, there are two layers, homogeneous and heterogeneous. At the same time, based on the temperature and the density, there are various other types of layers existing in the atmosphere. So now, like put together, total we have 5 layers. 3 layers will come under the homosphere, and other 2 layers come under the heterosphere. So again, under that homosphere, as we have discussed, up to 90 kilometers this homosphere exists in the atmosphere, that layer. So the lowermost troposphere is the lowermost layer of the homosphere, where 75% of the total mass of the gaseous mixture is composed of nothing but your troposphere. So this exists up to 8 kilometers at the poles, and at the equator point it is up to 18 kilometers. Average, we have 13 kilometers of this thickness of the layer surrounding the earth. This is the lowermost layer surrounding the earth crust. So the entire weather phenomena, like precipitation, condensation, and your transportation and the wind, cyclonic effects, all these kind of weather phenomena, rainfall, existing in this troposphere only. So above the troposphere you don't find this kind of different effects like cyclonic effects and others. So the entire weather phenomena you will observe only in the troposphere, only up to 18 kilometers thickness, and all moisture, dust particles also you will get in this troposphere. So at the equator, I told you that 18 kilometers. Why the thickness at the equator is greatest when compared to the poles. Why? Because of this heat from the equator side we transported to greater heights at that point. So why? Because it's due to convectional currents. These convectional currents forming the thickness of the layer, of at the equator is huge comparatively at the poles. The reason why, which is having 8 kilometers from one end and 18 kilometers from the center, this troposphere exists. And also, as you grow height from the surface, and you will get the temperature is decreasing. For example, you are going 5 kilometers height, or where these aircrafts and the parachutes and all you observe. So there you see the temperature relatively from the earth's surface is low. For example, if you are finding 28 degrees centigrade Celsius temperature at the earth's surface, if you are going around 6-7 kilometers height, you will get 26 or 25. That means temperature is decreasing. Temperature is decreasing when you are going towards upwards, and that too in the troposphere. That means within average of 13 kilometers. That is called normal lapse. Normal lapse is nothing but temperature decreases when you go upwards height. After troposphere, so which is existing up to an average of 13 kilometers, and we have the second important layer, atmospheric layer, homogeneous atmospheric layer, stratosphere. So as you know that at the equator it is 18 kilometers and at the poles it is 8 kilometers from the Earth's surface, the layer thickness. From there up to 50 kilometers we have this stratosphere, and this stratosphere is free from the clouds. Free from clouds means there is no further weather associated phenomenon like cyclones and rainfalls, precipitation, condensation, and all this kind of weather phenomena is not going to take place in this stratosphere because it's free from that particular weather phenomena. And so this stratosphere ideal for flying jet aircrafts, jet planes and other aircrafts. So usually you see the international air freights moving in this stratosphere, not in the troposphere. As you know, just for your knowledge, up to 6 kilometers parachute can fly, and where they experience the troposphere part, and 4 kilometers you can see the usual aircrafts like two-man aircrafts, and the commercial planes move around 10 to 12 kilometers height from the surface, whereas spacecrafts, satellites and all, they exist above 400 kilometers to 800 kilometers height from the Earth's surface. So why? Because the troposphere has got the more dense composition when compared to stratosphere. Stratosphere is having the free from the clouds, and it's ideal for the flying jet planes. Yeah, it's very interesting part of stratosphere. We have to discuss about the ozone layer. Ozone layer is nothing but the life layer which is existing from 20 kilometers from the height of this Earth's surface to 40 kilometers. So this is the layer which is protecting us from the sunlight and from the harmful rays of sunlight. So this ozone layer is very important for us to learn and understand. So existing from 20 kilometers to 40 kilometers, that means it is within the stratosphere. And this ozone layer also we call as a life layer, that which protects life on the Earth's surface. So if the sunlight passes through the ozone layer without stopping, so it will give us skin diseases. The rays will form the skin diseases and other stuff. So the stratosphere is again the very important part of the stratosphere is, as we have discussed in the troposphere, if you are going upward, you feel cool, the temperature cools down, the temperature goes down, called as normal lapse. Whereas here in stratosphere, if you are going above 18 kilometers height, if you are going towards upwards, the height or the altitude, if the increases, height or altitude are the same. Height also you can call altitude. If altitude increases, if height increases from the earth's surface, you feel the temperature also will increase. Temperature also will increase. Increase in the temperature. As we have taken the earlier example, like if you are going height, for example, if you are climbing any mountain, you feel relatively cooler when compared to the earth's surface from the thing. Whereas if you are going above 40 kilometers, say around 35 kilometers height from the earth's surface, you feel very hot because the temperature also will increase. It's like, so that is a very important part of stratosphere. So now after discussing this troposphere and stratosphere, the third most layer, the third layer of our Earth's surface and atmosphere, so the mesosphere, which is existing from 50 kilometers to 80 kilometers and an average of 80 kilometers, this mesosphere is existing, which is the top or underlined by stratosphere. So temperature again here it decreases if you are going upward, like if the altitude increases, if height increases, again the temperature decreases. So after completion of stratosphere, so you get the mesosphere. The difference between stratosphere and mesosphere layer is once you reach around 50 kilometers, and then if you are going again upward, again temperature will decrease instead of increasing. So like normal lapse we have observed in the troposphere, similarly we will observe the similar kind of temperature fall if you are going towards higher side in the mesosphere. So meteoroids burn up in this layer. Meteoroids moving around the space, and they protect us. Like before reaching from the space to connect with the earth, they burst there itself. There is nothing but mesosphere. In that mesosphere, these meteoroids will burn up. They won't reach to our earth's surface and they won't hit us. At the same time, we have the other layer, interestingly, the thermosphere. Thermo is nothing but heat. Heat is nothing but due to ions. So this thermosphere existing from 90 kilometers, here I kept similar 80 as we have already discussed. At the poles it decreases and at the equator it increases. So put together 90 kilometers to 400 kilometers, you get this thermosphere where all these radio waves, this mobile phone, all these waves are reflected in this thermosphere. Why it is reflecting? Because this layer is composed of complete ions, fully electrically charged ions. These charged ions, they once if the wave is transmitting from the earth's surface to the space, and in this space there are some ions, they reflect back these waves, so that you will be getting your TV channels, radio, FM radio, and mobile phone signals. All these things happens only in this thermosphere, because here the waves are reflect back. So the waves which we are transmitting from Earth's surface will reflect back in this thermosphere. The reason why we call this as a ionosphere. Thermosphere is also called as ionosphere. So here again the interesting part is, just like in our stratosphere, temperature increases if you are going towards upward, that means if height increases, temperature also will increase. That means here, interestingly, again I repeat, in troposphere temperature falls if you are going upward. In stratosphere temperature increases if your height is also increasing. In mesosphere temperature falls if you are going upward. Again in the ionosphere or thermosphere temperature increases if you are increasing your height. So that is about thermosphere. And the fifth, the exosphere, which is the uppermost layer of the Earth's atmosphere, is covering beyond 400 kilometers to 800 kilometers and extra kilometers. Why? Because very little known about this exosphere. The reason why outside, exosphere is the layer which is existing above the thermosphere. So, and scientists are still discovering a lot of information from the exosphere, which is still, it's not fully known, very little known about the exosphere. Yeah, students, now we understand about the air pressure. So what is air pressure? As we know, air is nothing but it composed of gaseous molecules. When these gaseous molecules, if they push each other, if they, bombard, and if they have a sort of, if more molecules are present, so they push each other, and this pushing, when they meet other molecule, they exert a certain energy, a sort of pressure. So this pressure is nothing but your air pressure when you observe this pressure in the air. So all gases has got their own pressure. So it's called nothing but air pressure. So usually if you get more molecules in the air, the pressure also will increase because of this more molecules bombard with more other molecules among the others. So, and why this happens? Because of the gravitational pulls. Because if the gravity is pulling down these molecules, they bombard each other, the other molecules, with that molecule. So this kind of air pressure is you observe in the air. And we discuss about this. Once if you heat any gas, for example, if you see water, if you are heating the water at the 100 degree centigrade Celsius, you will see water is transformed into water vapor. And this water vapor, have you observed that it's going down or upward? It's going upward because the gas molecules are becoming lighter. If you feel less molecules and they go upward. So the reason why the heat, if you increase the heat, the pressure will decrease. If you decrease the heat, that means if you are cooling them, these molecules which are blown out here and there, again they'll fall down, they come down closer, and again they become the dense. The reason why the heat increases, the air pressure decreases. Similarly, vice versa, if heat decreases, I just write this, if heat decreases, pressure increases. This inverse relationship called as inversor relationship between heat and air pressure. So these gaseous molecules which are heated, that the reason why, if there is more dense molecules, then you feel more pressure inside that, and if there is less molecules, less pressure. Usually what happens, this air pressure travels, these molecules travel from the high pressure zone to the lower pressure zone. For example, if there is no, because they want to travel, this traveling happens when there is a space. They see the space where there is no pressure at all. The reason why this air pressure transmits from high pressure zone to the low pressure zone. Pressure belts. So now we discuss about the pressure belts. So as we have seen the globe, so the complete semicircular zone is nothing but the belt. So the air pressure varies from one place to the other place. So like at the different rates, the heating and cooling takes place on the earth's surface. So as you have seen in the like for example in the water, if you heat the water, it takes time to heat. Whereas the land, it heats very quickly when compared to seawater. And land near the sea also heats very slow, not completely slow like seawater, but relatively when compared to the land, it heats slow. And at the same time, the falling of the temperature, the cooling also takes place at the land is very fast and sea very slow, and this land near the sea slow. It's like a mid of the land and sea. So this kind of cooling and heating varies from one place to the other place, also will affect the pressure belt. So there is a reason why the air pressure and the pressure belts varies from one zone to the other zone. For example, at the poles you feel higher pressure belts, and at the equator you feel low pressure belts. So Earth's surface does not heat uniformly. So at different places it heats up in a different pace. Land near the sea has got a different temperature phenomena, heating and cooling, and land near the surface, near the sea and at the sea, it differs. So the air above the land has got a different phenomena or a different heating and cooling thing, and air above the sea also has got the same. For example, air above the sea heats very slow and cools very slow. Land near the sea heats quickly, fast, relatively fast, and also cools down fast. Inland land, that means the inland land having, it's fast, very fast, it's very fast, so it heats up very fast and also cools down very quickly. Similarly, it's fast and slow, and this is very slow and very slow, both the cooling and heating. So the air also is having the different temperatures and different places. So the reason why we have to understand about this pressure belts, where there is a land, where there is a sea zones. So this heat, the solar radiation which is falling on Earth's surface differs from one place to other areas. It's just because of the land or water which is receiving this solar radiation. That will affect, that means the temperature variation will affect pressure variation around the world. For example, at the equator, these latitudes, 0 degree latitude, we have the high intense solar radiation when compared to the polar regions. At the polar regions, the intensity of this solar radiation is lesser when compared to our equator, so the tropical zone. So this tropical part, north hemisphere and southern hemisphere, tropical parts, they get more solar radiation, and at the same time at the polar and the subpolar regions, they get the less solar radiation. The intensity of the heat is relatively very less at the poles, and at the equator it's more. So again, that makes the difference in the air pressure. So usually wind travels from higher pressure zones to the lower pressure zones. Like water travels from the higher altitudes to the lower altitudes. For example, from the top, water falls from here to here. That means higher altitudes to the lower altitudes. Similarly, wind, that means air, travels from higher pressure zones to the lower pressure zones. So this moving air, which is called as wind, wind has a different names by its characteristic. For example, if the wind is moving very comfortably, peacefully, the pace is cool, then we call as breezes. It's nothing but breeze, sea breeze, land breeze. You feel very comfortable, that zone. When the wind is very fast at the shortest time and shortest period and a burst, then we call as gust. And if wind is very fast, like for the longer time, we call as storm. And if it continues in high intense with very fast and longer period, we call it as a cyclones. Cyclones having the hundreds of kilometers per hour speed. The wind speed, the air speed is the hundreds of kilometers is nothing but your cyclones. So wind is noted with the speed and also the amount of the air which is carrying, the mass of air it is just carrying. So as you know, if you are comfortable and then you are saying the breeze, that means you are getting the lesser amount of the air touching your body. For example, if you are hundreds of kilometers of air is moving and it is hitting you, so you will thrown out like it's nothing but your storm. The same wind, but the power is different. So the names also different from the one to one. So taking into consideration about the air pressure and the heating process of the solar radiation. So now we will discuss about the pressure belts clearly. So at the equator, as we have discussed, at the equator the solar radiations are high and intense. So the air molecules which are existing above the land or above the sea on this zone get more heat, and this hot air will go upward. As we have discussed in earlier classes, that once if the molecules are become lighter and the number of molecules also become smaller and shorter, and they blow upward. So this blowing upward of these air molecules makes that area, the pressure will become also low. The reason why this equator zone is nothing but low pressure belt. We call as low pressure belt. Taking into consideration about the equator, this is coined as a equatorial low pressure belts. Equatorial low pressure belts. So now the heated air, these heated air molecules, once if are going upward, it's not that they're the path which they have taken going upward, it's not that again they're going in the same path, like they're not solid particles, like they go in the same direction. It's not like so. It's a gaseous molecule, as we have discussed earlier. If they go upward, again they take up the different direction. It spreads in a different directions. Not they won't come back in the same direction they went. So that is a very important thing, that these air molecules are going to, some of the molecules going towards the north and some of the air molecules, these gaseous molecules are going towards south part of the earth globe. So these tropical zones, the air above these tropical zones, again similarly they are converging from one zone to the other zone. The reason why this zone also called as intertropical convergence zone, in short ITCZ, intertropical. The tropical zones from northern hemisphere and the tropical zone of the southern hemisphere, the air is converging and this zone is nothing but ITCZ, is having the low pressure because the heat is more. Once the heat is more, the air molecules are going scattering, spreading here and there. So similarly, once if they cool, they come closer, they sink towards the Earth's surface, and again the molecules become dense. If you are finding the dense molecules, more molecules, so recall, if the more molecules means more pressure. That means similarly in the cooler areas, in the cold regions, the molecules are very dense. So dense means high pressure zones. So always remember, this polar belts are high pressure belts. So high pressure North Pole belt, high pressure South Pole belt. So as we have observed, at the equator, the molecules which are highly, due to this high intense of solar radiation, are heated up, and these molecules are going upward, and again they take back the different direction as per once if they go upward, and they may move towards the south and towards the north. But at the same time, once if they get cool, so again they sink down to the Earth's surface, so forming this subtropical zone with high pressure. So that is very important and very interesting. So these molecules which are going upward, it's not that they are going away to the exosphere, again it's coming back to the Earth's surface. So this coming back or falling here, making this zone high pressure zone. So we usually call as subtropical high pressure. Similarly, subtropical high pressure zones. And this is towards southern hemisphere, and this is towards the northern hemisphere. And we have this latitude, as we know, Tropic of Cancer, and this latitude Tropic of Capricorn. So around these latitudes you have the high pressure zones, and the low and you will find the center equatorial low pressure belts, because of the more radiation of the solar radiation. So these air molecules which are going upward from the surface of the Earth due to the Earth's heat at the equator. So once if they are cooling down, they again come back to the surface, strike at the surface, and will become two parts. And one part, as you know, this low pressure belt, that means, as we have already discussed, wind travels from high pressure belts to the low pressure belts. That means this air molecule, once if it is traveling and striking the Earth's surface and dividing into two parts, one part goes back to the low pressure belt. That means again it comes to the equator. Similarly, here at the equator, the air molecule which is falling in the nearby southern hemisphere is touching, one strikes here and other is moving towards south and other moving towards north. So this cyclic wind called as equatorial cyclic zone, where you get the low pressure. And similarly here in the subtropical high pressure zone, we have the land air above the land of or sea in this tropical zone having more higher pressure is having more rainfall at the same time in the polar areas. So these polar winds, once if they strike the winds, so we get the different kind of rainfalls that's called monsoons, that we learn in the next class. According to Coriolis effect, winds traveling, the northern hemisphere travels towards the east part. The wind travels towards east, and in the southern hemisphere, wind travels towards west. So, according to Coriolis effect, at the equator, it's having the effect is 0, and at the poles, the effect of the wind is the maximum. So that's about the Coriolis effect. Yeah, this Coriolis effect is impact of Earth's rotation. Earth rotates on its own axis. The reason why we get the slight changes in the direction. So atmosphere always around the world is always in circulation. So, and winds play a major role in this climatic and weather patterns. That means at the tropical regions you have less rainfall, subtropical regions you have more rainfall. So this kind of patterns are mainly because of this winds and winds direction. Yeah, hi students. Now we'll discuss about the classification of the winds. Based on the wind direction, wind speed, wind features, and wind occurrence, where it occurred. So based on these parameters, winds are classified into majorly into 3 types. So today we'll discuss about the classification of the winds and what exactly their features and what direction they move from, as we have discussed, like high pressure to low pressure belts. So in which direction, whether it is east to west or west to east. Okay. So basically, as we have discussed, wind has a different a speed, occurrence, and the direction also, that characteristics. So based on these 4 parameters, so winds are majorly classified into 3 types: planetary, seasonal, and local winds. So planetary winds are majorly the wind, the moving air above the world, the sphere. So where you have the changes continuous, like like yearly, they have the climatic conditions, whatever we discuss, they're all planetary, they're all earth. So we don't have much effect of the planetary winds, they are continuous. So majorly they are again divided into 3 types: trade winds, polar winds, and westerlies. So the main characteristic of trade winds are they move from east to west. So from east direction to west direction, also called as easterlies, traveling from eastern part of the world to the western part of the world. Again, we have westerlies. Westerlies travel from west to east. So this is the type of winds, like they travel above the earth, which are like earthy. Yearly you have this climatic conditions. And polarlies, like trade winds, they also travel from east to west, east to west. So also part of. So these winds you generally find in the polar regions, where, as we have discussed, there you have the lowest temperature, cold regions, having, for example, if we take a moon, during the daytime it's too hot that man cannot tolerate. At the same time, during night it's too cold, again human being cannot tolerate these temperatures. So this kind of temperatures that we discuss yearly base, like we say America or Finland, it's too cold. That means it's a nothing but planetary winds. And whereas if you say in India, we have for every seasons, for every 3 months or 4 months, we feel a different type of climatic conditions. This kind of winds we call as seasonal winds, which are having restricted to the regions. For example, we say that in Rajasthan it's too hot, and in Shimla it's too cold or cold. This kind of words that we discuss, it is generally, it's nothing but the effect of seasonal winds. So seasonal winds are not yearly. For every season, like in summer hot, in winter we feel cold. So this kind of seasonal winds we call as restricted to regions or specific areas that where we live in. And local winds are every day, every 10 minutes you have a different type of weather. So the reason why the word which I am using here is climate, here weather, because weather changes, like for every 10 minutes, every half an hour, every 1 hour we feel a different. Say for example, in the evening we feel a bit cold relatively to the 12 to 2 in the mid of the day. So this kind of local winds have the characteristic, and they are not in one direction. The directions will change randomly, because sometimes you feel the direction from east to west, and maybe after 2 hours again west to east. Such winds are called local winds, and they are restricted to smaller areas. For example, your small colony, you feel a local wind effect. So rainfall in India is majorly affecting our seasonal winds. So due to this seasonal winds effect, we get the monsoons, like southwest monsoons we get, and also northwest monsoon in winter. So in summer we get this monsoons, like southeast trade winds will travel and will cross the equator, and there which we get in summer, this effect we feel from the southeast trade winds. At the same time, northeast trade winds will cross the equator, and we get in the winter we get the monsoons. So likewise we discuss seasonal changes, rainfalls, all in the seasonal wind effect. At the same time, local winds are again divided into two types, hot and cold. So these hot cold winds, like when the land is heated up, and when it raises the temperature, so the air which is blowing, like sometimes we call as a loo, it's nothing but hot local wind effect. So at the same time, we say that once if you go nearby the sea, we feel the sea breezes, very pleasant air moving, and we feel land breezes and the valley breezes. So all these examples are nothing but classics of local wind.